Let's implement the bisect method in MATLAB. So I'm going to write a new function. I'm going to call it bisect, and it's going to take 4 inputs. So we can tell from that that this is a little more complicated than what we've worked with before. So I'm going to call them f, x negative, x positive, and ERR. So what are these? F is a function handle. It's the function that we want to find a 0 of. X negative, that is some input value where f of x is negative. X positive, it's an input value where f of x is positive. And the whole point is that if f is continuous, then by the intermediate value theorem, there is some 0 somewhere between x negative and x positive. And one of the things I want to emphasize in this unit is that we should never expect to find a 0 exactly. So instead, we're going to try to get within this error threshold of a 0. So let me put in some comments to explain what we're trying to do. So ideally, we want to find z such that f of z equals 0. Okay, and because of numerical precision, okay, instead we want to find x0 such that absolute value of x0 minus z is less than our error threshold. And x0 and z, these are both between x negative and x positive. So in particular, I don't know which is bigger and which is smaller. I know the output of this is smaller and the output of this is bigger, but I don't specify that this one has to be smaller than this one as far as the inputs. Okay, so all I'm saying is that it's between. I'm not saying that x0 is strictly bigger than x negative. So my output, it's not going to be the exact 0z, it's going to be this approximate 0, x0. So setting it up is the hardest part, but then actually finding it isn't that hard, and we're going to find it using a while loop. So let's just start out assuming x0 is equal to x negative. Okay, this is just an approximation. And then while, so what do I want to do? I want to find some 0 that's between these, or some approximate 0 that's between these, and I want it to be within ERR of the actual 0. So what's the main idea? Let's say while the difference between them, so I know I have some bounds, x negative and x positive. So while x negative minus x positive. Okay, so while that's big, so while that's bigger than or equal to error. And then what do I want to do? I want to cut this interval in half, the interval from x negative to x positive, and I want to replace either x negative or x positive with that new bisected point. Okay, so let's let x bisect, okay, let that equal x negative plus x positive over 2. So this is a point that's exactly halfway between x negative and x positive. Then if, so I want to know, should I replace x negative or should I replace x positive? So if x negative, if x bis is less than 0, okay, then I replace x negative, okay, because this input could be a negative input. Okay, otherwise, then I'm going to replace x positive. Okay, and that's really all I have to do. Then anything, once this while loop is done, so once it's squeezed the bounds down to something that's ERR, smaller than ERR in width, then I can just choose anything. Let's choose x negative. And then that's what I return, this x negative. So let me save it. I'll call it bisect. And let's test it out. So I want to test it out on some interesting function. So let's first set f. Let's set that to be x squared minus 2. So I'm going to use f as a function handle. And then for my bisect, so f I put here. I want some input where the output is negative, so 0 is good for that. If I input it, I get negative 2. Then I want some input where the output is positive. 2 is good for that. If I plug in 2, I get 2. And then I want some error threshold. Let's do 0.0001. All right, and that looks pretty good. Let's test it out. Because what's a 0 of x squared minus 2? So I want some x such that x squared minus 2 is 0. So I want some x such that x squared equals 2. Okay, so an exact 0 of this is square root of 2. And yep, that's the same thing. So let's try another one. Let's try g equals the sine function. And now let's try bisect. And just to make it more impressive, so what are the zeros of sine? Zeros are all integer multiples of pi. So let's try to find pi using our bisect function. So here's an easy mistake to make. 2 is smaller than pi, 4 is bigger than pi. Okay, so it'd be really easy to try this. But 2, that didn't work. So what went wrong? The problem with this is that 2 and 4, okay, 2 is smaller than the 0, 4 is bigger than the 0, but that's not what I want. I want sine of 2 to be negative, and I want sine of 4 to be positive. Okay, and that's the exact opposite of what it actually is. Okay, so if you think about the graph of sine, is it positive or negative before it gets to pi? It's positive, so I need to flip these. Let's do 4 and 2 instead. Okay, and now that's a lot better. To make it more impressive, let's change the format to long. And so we can see that it's not exact, but if I want to make it exact, or more exact, okay, look how similar that is to pi.